Hi, I'm GUO CHENG GUANG of Primary 6 from YUMIN Primary School. We are now at methods of limit calculations. But for this time, are we going to have some more magic? Are we going to have, well, obviously more examples. So for this time, I'm going to show you two methods. The first method might seem similar, but the second method, I'll change it. It'll be different from the previous lesson. Okay, so this example here is a sigma, and from 2 to infinity. Then what is this about? You have n times n plus 1, n plus 2, then you have to over 2 to the power of n minus 2, this thing. So is there any changes we can make when you change it to 1? It doesn't seem right, because 1, when you sub it in, you cannot make anything a 0, so that is not right. You also cannot change it to 3, because when you sub in a 2, it's not a 0. So we can only have it like this. I'll first use method number 1. So of course we'll have to let fx be equal to like this. But this x0 power, what can I change? Can I be n minus 1? Well, I recommend this is the best, because if you're like n minus 2, you have to times another n, the x, then have to divide another x. If you say it's n, just n, then you have to take out an x, and then there'll be an extra x there, and it'll make things difficult for you. So what can this be? So of course, integration and differentiation. Problem is, which one first? Very obviously here, I've chosen this as a power, so that means it is integration first. But integration boundaries, what to start from? 0, 1, -1, 2, -2. Don't need to care, because after that, when you sub these in, it becomes a constant. And when it becomes a constant, they'll differentiate, it just becomes a 0. So 0, simple, you just start with 0. So first time integration. Like this. Not enough. 2 more coefficients to go. Second time integration. But at the same time, you have to differentiate them, because leave them at the end, and then you can use the geometric progression. Still not enough. 1 more coefficient to go. Third time integration. Like this. Now we have 3 of this. Is it okay for us to use geometric progression? Yes. It is okay for us now. So, geometric progression, let's use it. Now this part, you really have to focus. You have to be careful extremely careful about the first term and their ratio. First term, what is it? X to the power of 4. X to the power of 4. You have to be careful. What happens? Times. You have to be extremely careful about your multiplication. Then after that here, 1 minus the ratio, n and n. So that's simple. X over 2. But this fraction in the denominator, it gives us a headache. Why not just take 1/2 from here? But it is a half in the denominator. Reciprocal 2. Wait. So it becomes like this. Be extremely careful. So first time differentiation. Right now, I'll just write this in a power form because I'm more used to this power form. Like this, first time. Now that, second time. That means for this denominator. Now this is using the product rule. Do you have any ideas why is this still a plus? Simple. Power is a -1. Inside here, this is a minus x. Simple as that. Second time differentiation. First term, you have a 12x squared. This part, leave it as the same. Like this, second term, first term, same. So we'll just combine them in one step so that they will not get too long. Then after that, for this part, but beware of this. That is a -2. A few changes I need to make here. This is a -3. And here you'll have a 2. Like this. Like this. This part again. But wait. Here is differentiate. So there's no more differentiation sign. Okay, last time differentiation. This part, 24. This part, -1, no change. You have a 12. But how about here? You can differentiate this part at the front, 24. 24 and a 12. 36. I mean, here's a square. Here, what if you differentiate this part? You have an extra 2, 16. Then here's an 8, 24. Then this part plus 2, but wait, 3. So you have a 6. What do we have now? Simple. Sub it inside. So what happens? 1, 1, 1, 1. So it's basically 2 times 24 plus 36 plus 24 plus 6. This is just simple calculations. 180. Now this is just method 1. Now the calculations, you have to be careful. But what if I want to make it a simpler method? Do I have any way of making it a simpler method? Well, okay. So maybe, for example, that's method in the last lesson. That's second method. But can I just use that? Okay. So method 1, take a good look at this. Second method. Method 2. So what do we need? Still a net. 2, I don't want to care about that. If I don't want to care about that too, what could possibly happen? 2x to the power of, now this is definitely n minus 1. If you want n minus 2 is also fine, but it's just that there will be an extra x there. Would you rather get an extra 2 or an extra x? Of course, it's a 2. X. You want to know how messy it will get. Getting this. So this part, what happens? Well, you'll just get an extra 2 out here. Then d over dx. Integrate. Simple. 2 times. Simple. How about 3 times? Now this is what we need. No coefficient. Now we'll just straight away apply for the geometric progression. First term, x to the power of 4. Ratio, 1 minus x. Simple. Is it right? Then what happens? But be careful, this is x to the power of 4. You have to be very, very careful of that. So, at this part, you can get extra negative. An extra negative so that this will become an x minus 1. Like this. But now what happens? This is to the power of 4. So what happens? But wait, I will continue this. This is a little bit more complicated. But now you have this square. What happens? simplify. So what you'll be left with is actually x plus 1. Like this. This part, we'll use our expansion. Simple. Now it becomes very simple. Differentiate once. Take a very good look at what happens. This part, is it right? Oh wait. Okay, like this. Delta here, 6x plus 2 Now sub in 1, no, half. So you have to be careful of what to sub in. Wait a second. I missed out one part. Like this. So that means this, well, is still a negative outside here. Yep. Then you have a 6 times. What is this? What is this part? So you have 2 to the power of 4. So basically 2 to the power of 4 is just 16. 96. 90. 180. Still the same answer. So basically it's correct, unless you made the same mistake. So for this question, are you clear so far? You need to realize these methods around you are making things simpler. If you use the wrong thing, it can become very, very complicated. Like you get a lot of exponential apparent reason, whereas you can just get something like this. So with all of these methods, I hope that you all are clear. So for these, we'll see you in the next lesson. And if you like our videos, don't forget to subscribe to our channel. See you in the next lesson, and thank you for your watching.